Hello. Today we are presenting on mistake proofing and quality at the source and concentrating on the use of the Poka Yoke. This presentation is by Pritish, Treese, Prajwal, and Vijay. This presentation will include waste from poor quality, methods for eliminating defects, statistical process control, modes of inspection, 100% human inspection, Jidoka, building quality at source, sources of defects, introduction to Poka-yoke devices, functions of Poka-yoke, and continuous improvement. First, we'll start with the idea of quality. Henry Ford described quality as what you are doing when no one is watching. It is the idea of having no defects in what you are making. For customers, quality is the idea of meeting and continually exceeding their expectations. In lean production, it is important to try to achieve quality. This is done through 100% inspection, SBC, Jidoka, Poka-yoke. Waste can happen from poor quality equipment. Often there's variability in machine operating that can cause defects to occur. Human error is also a leading cause in this waste. Waste is anything that doesn't add value to a process. Performing additional inspections can help eliminate this waste, but also can lead to overprocessing waste. Methods for eliminating defects that will be covered in this presentation are statistical process control, 100% inspection, Jidoka, and quality at the source. For statistical process control, it is the idea of sampling different types of machines and processes to be able to control the variability within it. Samples are collected from a production run to see if they are within specifications and tolerance limits. The samples that exhibit too much variability will be identified and often are what lead to defects. Eliminating these can be done through a variety of sources, which we will touch on later. SBC can also be used for production that is in large quantities, but it isn't good for small batch production.
Um, Hello, everyone. My name is Vijay Anthony, and I will be talking on the human inspection portion of today's presentation. Before that, let's go over the common modes of inspection performed. Line operators, process experts, engineers would carry different levels of education, knowledge, and experience. Line operators working with the process have in-depth knowledge on the working of the process and will inspect products and make decisions on the quality based on their knowledge, skills, and experience. For example, line operators finding a defective part and isolating it during its production, a quality engineer accepting a non-conforming part which can be reworked and made acceptable. All these decisions are only made through a person's experience and most probably using their common senses of vision and other human senses to make their key decisions. Visual inspection is the key method for judgment inspection. Informative inspection is based upon feedback, comments, and data obtained from the process and cross functional departments. Engineers use this information to check on processes and to improve equipment effectiveness and productivity. Process improvement ideas also generated from informative inspection. Source inspection involves investigating the origin and source of defects to perform root cause analysis or bring up temporary or permanent corrective actions to solve the problem. Source inspection also forms the major solution to solve most problems arising from a machine. Next, we go on to 100% human inspection, which is the traditional way of using human senses and judgment to check for presence of non-conformance in a product. Humans would usually use visual inspection to look for physical defects or use special checking aids or measuring equipment like fixtures, vernier calipers, taper scales, microscope to look for defects. 100% human inspection is carried out through either self checks or successive checks. Self checks. Self checks are performed by line operators who immediately check a product which comes out from a process before passing on to the next station. If any defect is found, the operator stops the line and perform investigation on the machine to check why the defect is arising. This is Yoke, which will be explained later in depth. If the problem is minor, the operator will fix the issue and would resume production. But when serious breakdown occurs, the operator would seek the help of an expert or a maintenance tech crew to help them with the problem. A defective part will not be passed on to the next station in the case of self checks. Self checks are also only used for single station or for processes that are located far apart. Next, we move on to successive checks. Now, certain work cells are machines with small cycle times, which would quickly process parts and move to the next station. Here, the operator would not be able to check his own product, but rather the next station operator would inspect incoming parts. If an operator in the next station finds a defect from the upstream station, he immediately alerts the concerned process owner to stop the line and fix the machine or process before sending more defective parts. So successive checks are mostly used when machines are located close by and most probably used in a work cell. Next, we discuss on the requirements for 100% inspection. Humans make mistakes and it's easy for them to miss important product features during inspection. Hence, it is necessary to have certain instructions to help them with the inspection of all critical points. Here, we use check sheets, which are used to help operators check for inspection areas and to check them off if they are good. It is advisable to use only 3 or 4 inspection points in a check sheet so that the operator is able to check each and every one of them within the constant cycle time. Pareto charts are also prepared from defect data collected from the line. It will help top management to know about the current situation of the line and help plan preventive maintenance schedules and corrective action teams to address those defects. If a defect is found, the operator stops the line to check for the defect, and it is very important to have and-on signals or status boards updated with the current status of the machine. People working around the line or all the process owners involved are supposed to be updated with what's going on with the machine. Next, we move on to the advantages and limitations of human inspection. The key benefits of 100% human inspection is that it is cost effective and it has better control over the process. The exact source of defects are found with ease, and there is accountability for the quality of products with human involvement. It is also effective in easily fixing defects. The limitations are some processes require small cycle times, and it is not possible for humans to keep up with the pace for inspection. Some products are complex to inspect manually, which can be easily automated. Also, there lies an inadvertent amount of error in each human inspection across the different stages, and this error adds up in every process and accumulates as a significant inaccuracy in the final product. An increase of cycle time due to human inspection is also another downfall. So, in general, human inspections are considered to be as good as automated and statistical sampling inspection when performed correctly. Automation isn't necessarily better and is only used when it is impossible for humans to find defects in the product. Next, moving on to Prajwal, we'll take on with Jidoka.
Jidoka refers to automatic control of defects. Automatic in the sense that the process has a built-in mechanism to stop the process when a defect is detected. Automation is the word given when the process is shut down automatically. And-ons, as you see in the picture, are the devices that provide signals in the assembly floor as you can when the worker is unable to finish the job if he's overloaded with work or there is a defect. In the picture, you can see that the and-on has three kind of lights, green, yellow, and red. The green stands for when there's no defects and the production is running smooth. The yellow stands for when there's a problem, but there's no need to stop the line, but they need to call for help. And the red stands for when the production has to be stopped and everyone is alerted of the problem and it needs to be fixed immediately. Quality at the source is a lean manufacturing principle, which states that the quality output is not only measured at the end of the production line, but at every step of the productive process. Uh, in a practical sense, it would involve, each operator checking his or own work before the part or component is sent to the next step in the process. And if there's a defect, it can be communicated by the installation of hand-on lights to signal that there's something wrong in the production line. Each worker must check his work and ensure that the product that he's sending is defect free. Sources of defects and its elimination. Source inspection is performed to find out the rate or root causes of defects. In most of the organizations, when a study was performed, the most common root causes for defects are missing parts, information, wrong parts, damaged materials, variability in processing conditions and parameters, improper tools and equipment, or human errors. And this list tells us that these are the main points that needs to be addressed when designing Poka mechanisms and making sure all of these points are covered and ensure that the product is defect free. Poka is a Japanese term that means mistake proofing or error prevention. It's a Poka is any device or mechanism that prevents mistakes from occurring, and it's a process of designing a mechanism or a device that prevents or warns about a defect or a mistake from happening. The concept was formalized and the term was adopted by Shigeo Shingo as a part of the Toyota production system. It was originally described as Bakayoke, but this name meant foolproofing, so then the name was changed to Pokayoka because the employees at the production floor were a bit hesitant and they were resistant about the word called Pokayoke or foolproofing. Rules of mistake proofing. Uh, the three rules are: don't accept a defect from the supplier, don't make a defect in the production process, and don't pass on a defect when sending it to the customer. This means that whenever we are receiving a product or a component from the supplier, we need to make sure that it's defect free. Proper mechanisms must be set for the detection. While making the production of the product or component, there must be certain means to take care or signals to take care that there's no defect in the product that's being produced or signals are produced to warn about the defect. And uh, don't we should not pass on the uh, defected component or product to the customer by making sure that there's necessary checks before sending it to the customer. Okay, Poka, Yoka, and process design methodology. Um, there is a series of steps that we can follow or rules that we can follow when designing Poka Yoke. Some of the rules are we need to make sure that uh, it is very hard to make the error in perspective of the uh, assembler, and it is possible to reverse the error if there is a defect that is committed or a mistake, and make sure that there is a signal that an error has been committed during production. Each processes should have error proofing to ensure that defects are not passed on to the next step, and that each operation has mistake proofing in place to ensure that only defect-free parts are accepted in the picture. We can see that to insert the same uh, sort of plug into both the ports, the person can get confused, and hence, uh, if there's a color coding procedure or proper symbols are used, it clearly shows the orientation and reduces defects and ensures there's no mistakes over there. Functions of Poka. There are two distinct types of Poka: regulatory Poka and setting Poka. Under regulatory Poka, we have control Poka, which is basically a device that shuts down an operation whenever it detects an abnormality, sorry, and thereby preventing defects in succession of items. These can be sensors or systems, and this is usually employed when the safety issue is concerned with the process or the criticality factor is very high. Warning Pokeyokes are devices like lights or buzzers that signal that there is an abnormality in the process. Setting Pokeyokes are devices that make sure that when the process is being followed, that the correct procedure is followed, and it can relate to proper loading of parts or the number of counts in a process. Example like locating pins on fixtures or counters.
Now let's see various types of Poka defined by Shinjo Abe. Shinjo Shingo. The first one is contact method. Contact method can be useful to prevent defects by checking product characteristics such as shape, size, color, attributes. For example, loading pins and sensors to prevent incorrect loading of part on fixture. The next type of Pokoyoke is fixed value Pokoyoke. It is useful for checking specific number of movements and operations to eliminate missing parts or failed counts, etc. And the last type of Pokoyoke is sequence method, which determines if all procedure steps were followed to prevent missing parts or operation defects. For example, operator has to load all parts in particular sequence before machine performs operation. Now I will discuss various Poka devices used in Poka system to detect defects. There are three major types of Poka devices: physical contact, photoelectronic, and energy sensing devices. All these devices has a wide range of operation, and these devices are used in various applications such as machine vision system, human machine interference system, and warning sensors. So moving ahead, physical contact devices work by physically touching something. Uh, this can be machine part or an actual piece being manufactured. In most cases, these devices send an electronic signal when they are touched. Depending on the process, this signal can shut down the operation or give an operator a warning signal. Limit switches and toggle switches are the commonly used physical contact Poka device. They touch the surface of of a product and product to sense product characteristic and realize the switch if a detect is found stopping the process. Moving ahead with another type of Poka device, a photoelectronic sensor is an equipment used to discover the distance absence of presence of an object by using light transmitter, often infrared, and a photoelectric receiver. They are largely used in industrial manufacturing and work based on a Hall effect. Photoelectric switches are the common Poka sensors used. Their operation is divided into two parts: transmission, where two units are used, one to transmit the light and other to receive. And photoelectric sensors respond to light reflect from other from object to detect presence. If the object breaks the transmission, the machine gets a signal to shut down immediately. And last, energy sensing devices work by using natural forces to detect abnormality in systems. For example, those devices such as vibration sensors, force sensors, accelerometer, and pressure sensors can be seen on the screen. The devices can be used as warning sensors to alert or signal the operator to the presence of the problem. These sensors use alarm lights or error messages to get the workers' attention. These sensors may be used in a conjunction with a contact or energy sensor, and the lights are connected to micro switches and timers. Another example of such system is human machine interference system. Almost all common human and process errors and variability are detected by human machine interference system. If HMI detects any error or an abnormality, it stops the machine. Human machine error interference also display error messages to help the operator detect the abnormality. Now let's see a video to experience the physical application of Poka.
Various types of sequencers and indicators are assembled on the fifth floor, and different work procedures and parts are used. For this reason, the cell production method was employed more than 10 years ago. The cell production method is suited to manufacturing various products in small lots. Mistakes occur because a single worker performs the entire work. In addition to skilled workers, quite a few inexperienced workers, including newly assigned ones, work at the production sites. To reduce mistakes, Nagoya Works started to work on improvement more than 10 years ago. Over the past 10 years, the number of mistakes has been reduced to 1/10. The e-factory technologies were fully mobilized to achieve zero mistakes and renovate the sequencer assembly cell on the fifth floor. Collaboration between workers and machines has been ensured. This assembly cell features a job instruction system, which was built by combining our sequencers and indicators. Now, let's take a look at the screw tightening job instruction system. There are two key points in the work: using the correct parts and installing the parts according to the correct method. In the screw tightening job instruction system, the indicator screen in front of the worker displays the type and number of screws and the type of electric screwdriver to be used. The LED lamp lights up to indicate the next screwdriver to be used. The worker can accurately take out screws and select the next screwdriver without checking the job instruction. The indicator displays the screw tightening position and tightening order. The color of the tightened screws changes on the display so that the next screw tightening position can be checked at a glance. In addition to instructing the work procedures, the system can automatically determine the quality of screw tightening by using the sensor installed in the back of the screwdriver. If a screw is not properly tightened, the red patrol light and buzzer informs the worker of a problem, and the screwdriver is turned off to prevent the worker from performing the next job. All the data of screw tightening torque and time is collected by sensors. The data is linked with the products, workers, and dates and times of work, and is stored in a database on a real-time basis to ensure traceability management. This instruction system has made it possible to standardize the work and eliminate dependence on the experience and senses of skilled workers. This cell production enables newly assigned workers to ensure high quality in their work. The work improvement is facilitated by analyzing the huge amount of data derived from the instruction system. For example, the work time of each worker can be identified based on the graph of the average work time. Intensive training can be offered to workers who take a long time to complete their work. The number of improperly tightened screws can be displayed for each worker. Effective training can be offered to workers who often cause screw tightening defects. The quantitative data is automatically collected, and the effect of the training can be checked at a glance. The graph showing the number of defects by work process helps identify the processes in which screw tightening defects often occur. Improvements can be made quickly by jig replacement and design change. The instruction system has helped standardize the assembly work. The man-hours required for training newly assigned workers have been reduced to 1/3 through pinpoint improvement activities. The familiarization period has been halved, resulting in a significant increase in productivity.
Every part should be communicated to the operator so that the operator should not make any mistake. And these parts further are further I'm sorry, these parts are further stored in the system so that they can be traced and the improvements can be performed as per requirement. Now Teres will talk about the problem in error proofing.
Mistake proofing is an ongoing process that will never be able to completely be solved. There will still be occasional mistakes due to human error or variability in machine. The goal is to reduce these problems. As Pokeyokes are introduced, the idea of a meta Pokeyoke is also introduced. That is, it is necessary to include a process to eliminate errors that may be introduced because of a Pokeyoke. These processes always need to be improved, and therefore the error that has previously been corrected by a Pokeyoke may not even be relevant anymore. And with these entirely new processes, different problems will occur and new Pokeyokes will need to be designed. There are 7 guidelines to Pokeyoke attainment. The first is quality processes. For this, you need to be able to think of different processes that may fit what you are doing and try different ways of doing something in order to improve a process. The second is to utilize the team environment. Communicate with frontline workers in order to find the best solution for a problem. The elimination of errors. Use different techniques of identifying and tackling these problems in order to eliminate the errors that are occurring. Eliminate the root cause of the errors. Using a root cause analysis can help to find the worst problems that may be happening and then figure out how those should be fixed first. Do it right the first time. Time is wasted when something needs to undergo the same process more than once. Doing it right the first time allows for this to not happen. Eliminate non-value added decisions. Learn how to do a process and make clear cutoffs to know if something was done correctly or incorrectly. Implement an incremental continual improvement approach. Efforts don't need to happen all at once, but always being willing to improve on a problem can help to eliminate a problem completely. With continuous improvement, consistent errors are often found by human error and can be attributed to an organization of a company and how they handle recruitment, retention, and motivation of their workers. Routine lean manufacturing audits are important and able to see where a company is performing at any given time. These also work well to communicate with workers to find out from them what they think is working well and what needs to be improved. Operator performance can often be improved by simply communicating with workers and asking them what they think is best to correct errors that have been occurring, as well as take their ideas to develop a Poka Yoke that is effective. That's the end of our presentation. Thank you.